Okay, hi guys, welcome to a new IMONST video. So in this video, we'll be talking about IMONST 2020, the first round, and then for juniors, it'll be problems 10 to 13, and then for seniors, it'll be problems, 5 to 8. Okay, so let's look at problem 10. Of course, this is the juniors version because the juniors and seniors are the same, so I'm not going to do it twice. Now, determine the last digit of 5 to the power of 5 plus 6 to the power of 6 plus 7 to the power of 7 plus 8 to the power of 8 plus 9 to the power of 9. Now, we can check them one by one. So we want to kind of make a little table about the powers, the last digit of the powers of 5, right? So we have, so maybe say 5n, right? Then the last digit. So I'll just use LD from now on. So if it's 5, 1, so 5 to the power of 5, so 5 to the power of 1 is just 5, 5 to the power of 2 times 2, no, 5 to the power of 2 is 5 times 5, 25, it's still, last digit is still 5. 5 to the power of 3, 25 multiplied by 5 gives us 125, so it's still 5. 5 to the power of 4, we have 625, the last digit still being 5. And then finally, 5 to the power of 5, giving us 3125, it's still 5. So we can make a tiny conclusion here. Conclusion here being that any 5 to the power of n will have last digit as 5. Okay, now let's look at the sixth one. So we will have 6 to the power of n, and then the last digit will be circled. So 6 to the power of 1 is just 6, 6 to the power of 2, 6 squared is 36, 36, so it's still 6. 6 to the power of 3, sorry, I just wrote my 3 a bit bigger now, let me change it. Now, 6 to the power of 3 is 216, it's still 6, 6 to the power of 4, 1296, still 6. Then last one, 6 to the power of 5, we have 7776, which is still 6. So for this one's conclusion, still 6. Any 6 to the power of n has last digit 6. Okay, so it's still 6. So we can confirm that this is 6. No, this is 5. This is 6. And then for 7 to the power of 7, so let's take a look at this one. So 7n, then last digit. So for 7 to the power of 1, it's 7, 7 squared, 49, it's 9, 7 cubed, 343, it's 3, then 7, 4, 2, 4, 0, 1, it's 1, 7 to the power of 5, 1, 6, 8, 0, 7, it's 7. So as you can see, it will be in the form of, so let's make a conclusion here, recurring unit digit of 7 to the power of n as 7931, something like that. Okay, so we need to see, so this is 7 to the power of 1, 7 to the power of 2, 7 to the power of 3, 4, 5, 6, 7. So 7 to the power of 7 will have last digit 3, as we can see here. Now let's look at the 8th one. So for 8 to the power of n, the last digit, so we have 8 to the power of 1 as 8, 8 to the power of 2 is 64, so it's 4. 8 to the power of 3 is 512, 2, 8 to the power of 4, 4096, 6. 8 to the power of 5 is 32768, it's 8. Side note, you don't need to just multiply the whole number by an 8, which is very gigantic as I'm doing here right now. What you could do is you could just take the last digit and then just multiply it by 8. So for 2, you multiply by 8, then you get 16, so the last digit is still 6, okay? So the conclusion we can derive from this 8 powers of n has repeating last digits in a cycle of 8, 4, 2, 6. Okay, so we need to check. So this 8 to the power of 1, 2, 3, 4, 5, 6, 7, 8. So 8 to the power of 8 will have a last digit of 6. Now for the last one, 9 to the power of 9, so 9 to the power of n, and then last digit, we will have 9 to the power of 1, 9 to the power of 2, 9 to the power of 3, 9 to the power of 4, 9 to the power of 5, we're just checking. So 9 to the power of 1 obviously is 9, 9 to the power of 2 is 81, so we just take the 1, 1 times 9 is 9. 9 times 9 is 81 again. And then again, this is 9, so it's just 9, 1, 9, 1, 9, 1, something like this, right? So for odd powers, it'll be 9, and for even powers, it'll be 1. Since 9 to the power of 9 is an odd power, so its last digit would be 9. So the last digit of 5 to the power of 5 plus 6 to the power of 6 plus 7 to the power of 7 plus 8 to the power of 8 and 9 to the power of 9 will just add up. We'll have 5, 6, 3, 5, 6, 3, 6, and 9. We will get 11, 14, 20, and 29. So the answer to question 10 is 9. Okay, so check if you have did it correctly. Now, moving on to question 11. So this question is counted as done, quite a long one. Now, find the sum of all integers between negative root 1442 and root 2020. So for negative root 1442, we'll just need to see what 1442 lies in between which square. So we see that 1442 is smaller than the next square is 1444, which is 38 square. And then it is smaller than 37 square, which is 1369, right? Then for 2020, we know that 2020 is smaller than 2025, which is 45 squared. And then it is larger than 1936, which is 44 squared. So if we square all of this, okay, then note that, remember that the 1442 is negative. So we know that root 1442 is larger than negative 38 and then smaller than negative 37, because since it's negative, so the inequality values are reversed. And then for root 2020, we will get root 2020 being larger than 44, smaller than 45. So let's plot it on a number line. We will get this one, root 2020, and then we'll have 44 here, 44. Then we would have negative 1442, and we have then we'll have 37 over here. Basically, finding the sum of all integers between these two means adding up negative 37 plus negative 36, adding up all the way to 44, right? So what we want to do is, since we know for a negative 37 there exists a positive 37 to cancel them out, right? So what we'll do is, we'll have 0, negative 1, negative 2, all the way to negative 37, and then we'll have 1, 2, blah, 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 37 to cancel all of these out, so all these terms become a 0. But we're left is we will have 38, 39, 40, 41, 42, 43, 44. So you see we have 7 terms here, and then we can see that the average being the middle value of these 7 terms is 41. So we can just multiply 41 by 7, then we'll get 287. And this will be the answer to question 11. Okay, so I hope you guys got it right. Now, moving on to question 12. So we have 3 brothers, and then they are owning a painting company called Tiga Abdul Enterprise, and they have to build a building. So this guy, so the first guy, Wahab, says, I can paint this building in 3 months if I work alone. Wahib says, I can paint this building in 2 months if I work alone. Wahub says, I can paint this building in 3 months if I work alone. Then if they work together, they can finish painting the building in 1 month only. What is K? So for some juniors, this might be quite a new problem, but think of it this way. Okay, maybe Wahib is kind of confusing, so we'll just label them as A, B, and C, okay? They say, so take for example Wahab, which I label as A. A can work in 3 months, right? A can paint in 3 months if he works alone. So it means that if we count the whole unit, okay, so let the whole painting job be 1 unit, which means that this A, Wahab, in 1 month, A can finish how many parts of the job? A can finish 1/3 of the job, right? And then for B can he can paint this building in 2 months if he works alone. It means that in 1 month he can finish half of the job. Okay, so C can finish this building in K months. So C in 1 month can finish 1/8 of the job, right? So we see that in 1 month, Wahib A can finish 1/3 of the job, and then Wahib says he can finish 1/3 of the job, and then Wahub, being C, can finish 1/8 of the job. Now, all of these three adding up together, they can finish the whole job in 1 month. So in 1 month, all three can finish one job, right? So what we want to find is just find 1K equals to how much? Then we want to find K, right? So we just have 1K equals to 1 minus a half minus a third would be equal to 1/6. So K here will be of value 6. So this might be a slight shift in perspective for some of you juniors. And then if you guys got this, maybe you can give me a thumbs up. I don't know. Asking for likes, oh my god. Okay, so this is the final question for the day. We have a rectangle ABCD with the point P inside it. So let's draw a rectangle. So it is something like this. Okay, then we have A, B, C, D. So either we do it clockwise or anti-clockwise. We can't say, oh, this is A, B, and then this is C, D. Okay, we must follow an order. Now, with the point P inside it, and then we have PA equals to 17, PB equals to 15, and then PC equals to 6. Now, let's just draw a few points, something like this. Okay, it might not be accurate, but okay. So this is PA. Then we have PB over here. And finally, we also have PC. Then what we want to find is the length of PD, right? So we also draw this line. Okay. Now, what is the length of PD given that PA equals to 17, PB equals to 15, and then PC equals to 6? Now, what we need to do here is we need to draw auxiliary lines, because a very important concept involved in this is the Pythagorean theorem, which states that for a right triangle, the two lengths, the two sides, a squared plus b squared, the shorter one, the squares will be equal to the hypotenuse, c squared. So it is a squared plus b squared equals to c squared. Okay, so we can draw auxiliary lines like this, and then like this. So we can kind of label them as, so we can see this one maybe say A, and then this one maybe say B, and then this one C and D. Then we see that this one is B, this one is A, this one is D, and this one is C. So we see that using this formula, we will have PA squared equals 17 squared equals to, okay, A squared plus C squared. And then PB squared, which is equals to 15 squared, is equals to B squared plus C squared. Then PC squared equals to 6 squared equals to, let me see, B squared plus D squared, and then finally PD squared equals to, we don't know, so let's say X squared equals to A squared plus D squared. Now, observe that when you add up PA squared and PC squared, it is the same as the sum of PB squared plus PD squared, right? So from here, we can just simplify this whole thing down into 17 squared plus 6 squared equals to 15 squared plus X squared, right? So our X is here. We just need to find X squared. Then maybe using a calculator, we can get 289 plus 36 minus 225, which will give us 100. So X squared being 100, X will be either positive or negative. Positive or negative 10. But since lengths can only be positive, so X of course is just 10. So the length of PD being X would be of length 10. Okay, yeah, so this is the last problem of the day. I hope you guys understood everything that I've said in this video, and then if you like it, just put a thumbs up and subscribe, I guess, for a bit more untimely content. I don't know, I don't really post videos regularly anymore. I don't even know what I'm doing. Now for the next video, we'll be talking about problems 14 to 17 for juniors, and then for seniors it'll be problems 9 to 12. Okay, so see you guys next time. Bye.